Hello, I'm going to show you different statistical techniques for pandas. We will talk about the mean, and we will also talk about outliers. Okay, now, if you're using, if you're writing Python code, you should save it in GitHub. So we have our example here in GitHub. So I click here to open in Colab. If you wrote it in Colab, then you can open it again in Colab. So this is a good subject to look at is salaries earned by data scientists. Now, this data here was submitted by actual employees, contractors, consultants, freelancers who uploaded their information and put it in Kaggle. So this is accurate information here. Should be, because it's been vetted. But anyway, so we proceed simply by importing pandas, and then we read this CSV file, and then we print it out. Now, this by itself is just too much information is to see if we can't get something from it. So what we have here though, is for example, we have what columns do we have? We have run this again. Uh, it showed AB because down below I have a different data frame. Okay, so it's got all these columns here. It has salaries for different job types from different countries and different currencies. So we'll use US dollars. So let's see here. Okay, let's try to do this. And here we do it all in one shot. You know, we get here. What we've listed here are salaries for data tech, data science lead, architect, engineers, basically everyone who says they're working in the AI data science field. So this is not unique because we have people who are in the same job in the same location, uh, who have submitted salaries. So we're not grouping by job title, but actually we are grouping by job title. But anyway, let's break this down. Let's break this down into steps. So look at here. So what do we do? So let's take all this and just copy it down below and look at it in steps. So, what we want to do is get average salaries. So that's mean for people located in these countries. So we'll break it down by steps. So first, we will use the logical operation. This, this DF company location, that's a series. So we can say is in. Is in just simply says, is it in this array? We pick people in the United States, France, and Germany. Okay? And then that's salaries. Then we print that out. Let's see, if we run that, that's going to create quite a long list because here I told it to display all rows here. Otherwise, Pandas normally prints like it truncates long lists so it doesn't make your notebook too enormous. So anyway, let's go down here. I want to show you if you add the group by operation to it, it doesn't create something that you can see. Instead, it creates a group by object. So let's see what we have here. Let's take the word salaries off of it for a minute and run this. See, it's a group by object. So it's gone through, it said, let's take all these, records, these rows that have this condition. Notice we did not use LOC. We used there's two ways to look at data. To use the .loc, or here when it's a binary lookup, you can say data frame, bracket, data frame, and put some logical condition in the middle. Okay, so we group by. Now, creates a group by object. Okay, now we cannot yet see anything. So what we're going to do here is we will go back and add the mean to it. And reset index. When you put mean on it, it will, that says go out, calculate something, and then show it to us. So we'll do that. Okay, now there are salaries. Average salaries grouped by the company location, like the United States, then by the job title, engineer, manager, pipeline engineer. These are people that work with Hadoop databases and so forth, I imagine, and things like Mesosphere. Data science consultant, that would be more mathematician kind. Data science engineer, I imagine that's a programmer. Okay, so I have reset index on here. Why do I have reset index on here? Because it causes it to calculate. Let's try it without reset index, for example. We'll see if there's a difference. So I've already instantiated this object. Let me do this. Let me do this. Clear all outputs. I want to reset anything that's been set. Do it step by step. Now I'm going to run one cell at a time. Click here. Read the data in using the read CSV method. Print out the first 100 records. Okay. Then let's skip over this since I'm going to do this line by line down below. So here, let's do this. We want to take off the reset index, see what it looks like. Okay, rim this out for a minute. Rim this out for a minute. I rim this out. So again, what are we doing? We're using the kind of Boolean way of looking up stuff. So we're saying here, company location is in these countries, and we just want last year. I recorded this in 2024. AI salaries have increased a lot in the last year or so. We don't want data from prior years. So let's take off reset index from it and see what it looks like. Okay, and then we'll print off salaries. See what this looks like? It's not a data frame. It drops it into a primitive. So we will do this again using reset index and see what it looks like. See, now it makes it a data frame. Not quite sure why that behavior is, but that's a requirement to have it do that. Okay, now, what is wrong with this? Nothing, except it's not sorted in. Why have I got less data here? I'm not grouping by job title. That's interesting. Well, okay. Somehow that was in the line above. So here, this is actually very useful. We can compare country to country. We can say the United States. Now I live in Europe. The United States average salaries are higher. They've always been higher than Europe. I don't know why. That's just the way it is. So Germany, here it is. If we want to sort this, let's now, sorting is very easy. We just say, okay, sort by company location, salaries in US dollars. Just say we want salaries in US dollars. Ascending equals false. Do we want the smallest number first? No, we'd like it the other way around. Okay, and then print it out. There we go. United States is on top. Significantly higher than Germany and France. And if we go up here, do this, where we are also grouping by job title, we can see here, well, this is by company location. This is what we want. We do want it by country. So let's print this out here, okay? So we're going to call this salaries. Need to assign it to something. If we don't assign it to anything, then it's creating a new instance of a data frame kind of in space, somewhere that we can't get to it. So we have to assign it to something. Print it out while we get this error. So I've rimmed out part of the code. So we have to go back here, put in the rest. See, when you do group by, it doesn't produce anything until you force it to calculate the mean. And you need to give it numeric values only. So we're going to use salary in US dollars. And you have to put the print statement on there in the end. There we go. So now we have it by country, by job title. There's a lot of job titles here, right? There's so many. There's a data scientist. That's the mathematician, right? He knows linear algebra. He knows set theory. He knows neural networks. And a lot of people in this field don't know the math, but they know the programming. What the data scientist knows is the algorithms and the math behind it, right? How to do gradient, for example. Okay, so anyway, now we're going to go back here and do the next thing on the list, which is to look at outliers. Okay, this is where I keep my code from my programming class. I teach programming free to teenagers and university students here in Eastern Europe, mainly Ukrainians. I'm located in Cyprus. Most of my students are in Ukraine, Cyprus, and Ukrainian refugees in Eastern Europe. So anyway, so let's go down in my list let's click on Pandas. Let's go to group by, sort, and statistics. Okay, again, I wrote this in Colab so I could open it in Colab. I store it in GitHub because this is what everyone else does. Google has a GitHub, Facebook, and Microsoft. GitHub is the standard place to put your work. Wait a minute, that's not the one I want here. Let me go back. I'm looking for get rid of outliers. Drop outliers. Here we go. Drop outliers. Open in Colab. Okay, so what is an outlier? Suppose you're gathering data for whatever it means. Example, it could be an industrial application. You have sensors all over your factory, all over your machine, measuring everything, measuring electricity, measuring emissions, measuring ambient temperature. Okay, if a sensor is flawed, it will yield bad information. If you run a data science model with bad information, you will get bad results. So we have to get rid of outliers. Now, if we go back and look at the normal curve, remember the normal distribution. If you do, um, multiple trials, it's called, to gather data, then most data is normally distributed. There is data distributions that are skewed. But things like, for example, student grades, people's heights, the average temperature of a machine is going to be normally distributed. We have this curve thanks to the mathematician Friedman Gauss, who shows. Okay, so the area under the curve is 1 all the time because that's the definition of a frequency distribution. It's a probability. So the probability that any data point is within 1, so here's -1, and here's +1. Standard deviation is 30.16%. Now, the probability that's within 2 would be the sum of these two things. Actually, the sum of these 4 things. This is in the negative direction. This is in the positive direction. So this is 68% in here. And then going out further, you have lower and lower probability. So the probability data is more than 3 standard distributions is 0.13 times 2. We can consider that to be outliers, right? So let's take a look here. And let's look at, okay, we've got 2 methods to look at. We're going to use the z-score method. The z-score is this. Here's the z-score for any number. You take a data point, you subtract the mean, you divide it by the standard deviation. And that plots it on this curve here. You know, z equals 1, z equals 0.5. Okay, so here we go. First, we're just going to create some random data. Okay. Now, I just you don't need to really study this code. I just have salaries and I have name, and I want to calculate salaries, and I'm going to use this as a mean, $10,000. $10,000. It's too low, obviously, and 25 standard deviations. So then I will draw on the normal curve. If I use the random Gauss function, that will create random values subject to a mean and a standard deviation. You remember, if you just use the regular random integer function, what does that do? That pulls from the uniform distribution, where each number has an equal probability. But the normal curve is as the normal curve distribution. So anyway, then here, what the idea is, we're going to make up pretend salaries for 20 pretend people, and then I'm going to create an outlier. So let's start off here. When you first open up your notebook, you'll get this message, and then you have to run it. It'll connect to Google's compute engine. That will take a second. Just take a look at the whole thing, make sure there's no errors. No errors, okay. Start at the top. All right, so we make the data here, okay? We're going to save the original data in something called data frame. But then we're going to call the salaries data frame salaries, and here we print it out. Say this person whose name is DEF, this is their salary. So as you can see, the data is pretty normally distributed. Now, I do have some missing values. I wanted to put missing values in there. Why? Because this is the whole point of cleansing data. Is if we have missing values in a numerical average, what's that going to do when we calculate the average? Well, if it includes NaN values, then the average is going to be wrong because skewed. Why? Because the average is the sum of the values divided by the number of values. What is going to be in the sum when we have NaN? Nothing. So the denominator will grow and the numerator will shrink. So we have to eliminate NaN values. Anyway, so Here, after you create a data frame, always look at info because it gives useful information. We have 20 rows. Here we have 20 with name, that's not empty, not null. 17 salary, not null. And then we have that's a floating point, 64-bit number. And then name is object. That basically means a string. So here we're going to drop the NaN values. So we get rid of the, I mean, what choice do you have? Okay. Someone did not put their salary in. Now, what we do in another video is that we show that and what you could do, like suppose you had more than 2 rows, suppose you had many rows. You wouldn't want to just drop the row when you have one missing value. Why throw away so much data? But here we've only got 2 columns, the name and then the salary. When you got just name and salary, you could, okay, actually the opposite case. When you have many columns, then instead of delete the whole row, it might be best to just set the empty values, the NaN values. NaN, remember, means not a number, to the average of all the other rows. That kind of makes sense, right? If everyone's making about $10,000 and someone forgot to put their salary in, then we can just say they make $10,000. Theoretically, that would not change the average at all, right? And then we preserve the rest of the useful data that person has given us, being like, you know, whatever else might be there, like where do they live, what is their title, etc. Here we have the mean now. 99,000. $9,987, sorry. Okay, look at info again. So now we only have 17 rows. See, we had 20, now we have 17. It dropped to 3 blank ones. Go back up and look. See, 1, 2, 3. So we got rid of those guys. Now, another thing here is, suppose we do have a number, but it's like a ridiculous number, like a 0, okay? Remember, NaN, when you import data from external source, Pandas import like read CSV will convert certain data to NaN, certain data to blank, certain data to 0. So if we've gotten rid of NaN values, let's see if we have any zeros. We run this. Now, remember, this is a logical Boolean. This is a Boolean. It says, give me the list of everyone whose salary is less than 0. And then we use the LOC function. You remember in the last one, we didn't do that. We did this. It's equivalent, but not in all cases. We have other videos on how to search for data. Hey, you could also do this. But these two things are different because loc lets you do things like tell it what columns to get, what rows to get, so forth. Came up with nothing, right? All right, so now let's calculate the mean and save it. We did that before. And now we're going to add an outlier. So here's what we want to do. We want to pick someone whose z-score is 3.5. We want them to be more than 3 standard deviations. And we'll define that to be an outlier. Is there a scientific way to do that? Not really. I mean, there might be in advanced statistics, but a good rule of thumb might be just to pick. I mean, you have to look at your data, see how it's distributed, but if we can pick beyond 3 standard deviations, that's good enough in this example, because we only have one person. Right now we have no people beyond 3 standard deviations. So anyway, So we need to solve this equation, z-score, for x equal 3.5, right? See, we have salaries in terms of 10,000, whatever. So we wanna find x, find x that makes z equal to 3.5. So we just solve this algebraic equation. It's this x minus mean divided by standard deviation. Multiply both sides by standard deviation. Eliminating the denominator, we get this simple equation. Then we just add mean to both sides. We get this, turn it around. So we know that x is 3 times the standard deviation plus the mean. So let's figure this out. Let's just multiply it out. We'll call this guy rich. He's rich. So if you make, this is not a lot of money still, $10,067, and you're considered rich in our category. So we will make a row called outlier. Okay, we give the name here, Alexi. Alexi is one of my students. Hey, Alexi. Okay, let's add Alexi to the data frame. How do we do that? Well, we just need to make another data frame with the same columns, and then we will give it an index value. So we say, here's his salary, here's his name, and then we concatenate. We use Pandas concatenate function to concatenate this new data frame, outlier, with salaries. Now, let's look at this. Okay, so we want to now create a new column called z-score for everyone. So what are we doing here? Let's break this down into pieces. So we are using this lambda function here, right? The lambda is an autonomous function, meaning inline. Remember, we had this score here, right? The z-score is x minus mean divided by standard deviation. So then we use the apply function, which means run this across every row in the series or the data frame. And then if we say salary z-score, that will create a new column in the existing data frame. So we do that, run that, and we get, here's Alexi with z-score, exactly what we wanted, 3.5. Okay, here's everyone else. Right there, and then there's z-scores. Okay, we do have one person greater than 2. So below here, I've said, show outliers to be anyone whose salary minus the mean is greater than 2 standard deviations. In other words, that is the z-score, right? So let's change it to 3 because I don't want these other people to be considered outliers. Run this. Why did it not pick up Alexi? I have to run everything from the top again because I've changed the data frame. Just start at the top. Run the first cell. Drop. We don't need info. Calculate mean. Solve for x. Create the outlier. Add the outlier to the data frame. Now, calculate the z-score. It is Alexi. He's got 3.5 again. Now, let's get people whose salary minus the mean. Let's figure this out now. So 100, what is he? His salary is this. Minus the mean. What is the mean? Well, we have it up above. Okay. The salary is only 74 above the mean. Now, is this above 3 standard deviations? What's 3 times the standard deviation? 63. Yes, it is. So let's see if it picks him up. It does. It gets Alexi. See how it works? So again, here's the Boolean expression. We use absolute value. Why? Because salary can be both, both above and below 0, right? So we get this Boolean expression to get the people that we want. Then we use loc to find the row. Okay, now let's again, let's set the threshold to be 3 standard deviations, not 2. Okay, so now the same expression exactly as above, except we're going to say drop. Okay, so we're going to drop Alexi from here. Is he here now? Well, he's not here anymore because we dropped him. I mean, how do we know we dropped him? We can always look at salaries info. I don't have the number from above, but we have 18. So remember, this could last time it was 17 because we drew from normal distribution. So each time we do that, we get new values because that's what random means. Okay, now the next one here, let's look at this. Interquartile range method. Here's another way to find outliers. Now, if you look it up, which one's better than the other? Well, you can do some reading about that. But anyway, so let's do this in a couple steps here. Okay, I want to create the data. Why am I dropping? Well, I'm dropping null values. Here we go. We create the data again. Dropping NaN values. Okay. Now, this here, we use a numpy's function. Numpy quantile. Okay. So we're going to say, give me, okay, take this data and divide it into intervals of 0.25. It's going to create an array. Okay, those are going to be 0.25. I have to look here for a minute. What the definition of numpy quartile is. I kind of forgot. Go back and use perplexity. You can use Chat GPT to write code. You can use perplexity just to, what is that? To scan the internet and read stuff and give you the answer. Let's read into numpy's documentation. Okay. It computes the qth quantile along the specified axis. Okay, so the main arguments are the quartile values and the axis along which to compute. Okay. For example, to use n quantile to compute the 25th, 50th, and 75th quantities for numpy array. Why did I not put that? Let's try it one more time here. Zero 0.5. 0.75. I don't need to put the endpoints. See what it does here. Okay, it gives me 1, 2, 3 values, which are going to be the 25th, 50%, and 75th. The three, divide 1 into 4 pieces, you're going to get 0, 0 0.25, 0 0.5, 0 0.75, 1 if you'd like to include the end. Okay, so let's describe what we have in salary. See, now this should give us the same information. See, we use the describe method. It says the 25th percentile is 9982.5. That agrees with what we looked up here. The 50th percentile is 9987. Which agrees with what we got here. The 75th is this one. And there's the max. Now, let's see here. Oh, I did this a different way. You could look at this number, which is a data frame, and grab this column and call that the first quartile. See, get this data frame, which computes count, mean, pluck any value out you want. So let's get the 25th, and, well, we might as well add it in here. Q2, 50th percent, and just print that out. I'm casting it to an integer because of decimal points. Just makes it longer to read. There we go. There are our quartiles. Now, the IQR is defined to be Q3 minus Q1. And then what we're saying here is, it's just the standard rule that they have. Okay, if the salary is less than Q1 minus, I could have done this with absolute value. Actually, if it's lower than Q1 minus this IQR, which is this difference, in the interquartile range. Let's see what that is for actually. The interquartile range is going to be the interquartile. So it should be from Q1 to Q3, right? That is what that means. All that's saying is if you're below the interquartile range or above it, then that's the valid data. Everything else is an outlier. So print it out. Here we go. Now, this just shows the calculation that it made. Now we're going to plot it. Okay, so we are going to use the cut method. Here's another way to calculate quartiles. Cut the data into quartiles. It's quartiles because we say use 4 bins, right? Then we'll call our labels Q1, Q2, Q3, Q4. Okay, group the data by quartiles to make a histogram. Looks like this. There you go. Run it again, just to make sure it's got the current data. So we have 3 in the first quartile, 5 in the second quartile, 3 in the third quartile, and 2 in the fourth quartile. Now, another way to look at that is you can calculate a histogram just by using value counts. Just prints them out. So here, that's using one method, value counts. Here we made a quartile by cutting the data frame into 4 bins. Okay, anyway, so I hope that was useful for you. And we will talk to you